this episode, we are going to make 4 important network ideas feel much easier and much more connected than they may seem at first. New learners often see domain name system, DNS, dynamic host configuration protocol, DHCP, virtual local area network, VLAN, and virtual private network, VPN, as separate topics that have to be memorized one by one. The better way to learn them is to see them as services that help devices find each other, get the settings they need, stay organized on the network, and communicate safely across distance. When one of these services fails, the user usually does not describe the failure by using those names. The user says websites will not open, the device cannot get online, one group of systems cannot reach another, or remote access stopped working. Once you understand the job each service performs, those complaints stop sounding random and start sounding like clues that point toward a specific part of the network. Before we continue, a quick note. This audio course is part of our companion study series. The first book is a detailed study guide that explains the exam and helps you prepare for it with confidence. The second is a Kindle-only ebook with 1,000 flashcards you can use on your mobile device or Kindle for quick review. You can find both at CyberAuthor.me in the Bare Metal Study Guide series. A good place to begin is with DNS because it solves a very human problem. People like using names, while computers really need numeric addresses to find one another on a network. If someone wants to visit a website, they would rather type a familiar name than remember a long Internet Protocol, IP, address made of numbers. DNS acts like a helper that translates the name into the numeric address the device needs. That is why DNS is often compared to a phone book, even though that is only a simple beginner picture. The key point is that DNS helps devices find the right destination when a user starts with a name. If that service is working, the network feels easy to use. If that service is not working, the device may still be connected to the network but unable to reach things by name, which creates a very specific kind of failure. Once you understand the basic job of DNS, the idea of a DNS record becomes much less confusing. A record is simply a piece of stored information that tells the DNS service something useful about a name. Different record types answer different kinds of questions, but at the A+ level, the most important idea is that records connect names to services. Some records point a name to an IP address. Some help direct email traffic. Some create aliases so one name can lead to another name instead of directly to an address. You do not need to be an advanced administrator to benefit from that knowledge. What matters most is understanding that when a device asks DNS for help, it is really asking for a stored answer from one of these records. And if the record is wrong, missing, or out of date, the user may end up at the wrong place or fail to reach the service at all. The most common DNS record concept beginners hear first is the idea of a record that points a name to an IP address. That matters because it supports the most basic and most visible use of DNS in daily life. If a company website, portal, or internal service has a name people type into a browser, there needs to be a correct record behind that name or the device will not know where to go. Another common idea is the alias record, which helps when one name should really lead users to another name that already has the main address information. This is helpful because businesses often want multiple friendly names for one service without having to build the same address answer again and again. Mail records matter too because email systems need a way to know where incoming mail should be sent. For a beginner, the main lesson is not to memorize every possible record type, but to understand that DNS records are stored directions, and if the directions are wrong, the network can feel broken even when the cable, Wi-Fi, and device all seem fine. DNS failure has a very recognizable feel once you know what to listen for. A user may say the internet is down, but after a few questions you may discover that some things still work while anything that depends on names does not. A website may fail when typed by name, but work if reached another way. One application may connect by stored address while another cannot find its service at all. Internal systems may disappear from the user's point of view even though the network connection itself is still present. This is why DNS problems often make the network feel half alive. The device can still speak in a general sense, but it has lost a major part of its ability to find who it is trying to speak to. For beginners, that is one of the most useful patterns to remember because it helps separate a naming problem from a total connection problem. DHCP helps with a different part of the network experience, but it is just as important. Before a device can browse, send email, join business tools, or reach a printer, it usually needs some basic network settings. Those settings commonly include an IP address, a default gateway, and often DNS information as well. DHCP is the service that automatically provides those settings to devices, so users do not have to type them in one by one. That is why most home and office devices can join a network quickly and begin working with very little manual setup. The device asks for what it needs, and DHCP responds with a usable set of network information. For a beginner, the easiest way to think about DHCP is that it gives a device its working identity and basic directions for life on that network. Without those settings, the device may be connected physically or wirelessly and still not be able to communicate in a useful way. One of the most important DHCP ideas is the lease. A lease means the device is allowed to use a particular network address for a period of time instead of owning it forever. This helps the network reuse addresses efficiently because devices come and go all the time. A laptop may connect for a few hours, a phone may visit for a few minutes, and a printer may stay connected for months. The lease system helps the network manage those changing needs without forcing a technician to assign every address by hand. When the lease is working normally, the user never notices it. When the lease process goes wrong, the device may fail to get an address, lose connectivity after joining, or receive outdated information that no longer fits the network. That is why beginners should think of a lease as temporary permission to use a network identity, and not as a permanent label fixed to the device for all time. A reservation is related to a lease, but it solves a different need. With a reservation, the DHCP service is configured to give the same address to the same device each time that device connects. That is useful for things like printers, servers, cameras, or other devices that people or systems expect to find at a stable address. The device still gets its settings through DHCP, but the result is consistent because the network has been told to keep assigning the same address to that specific hardware. This is a very practical idea for beginners because it sits between full automation and full manual assignment. You still get the convenience of central control, but you also get predictability where it matters. If a device that normally stays at one address suddenly appears somewhere else or disappears from where people expect it, that can create confusing support problems, especially for shared resources that many users depend on. DHCP failures also have a pattern that becomes easier to spot with practice. A device may connect to Wi-Fi, but still say there is no internet access. A new system may join the network and then fail to reach anything useful. One area of the office may have devices that work while a newly added device never gets fully online. In some cases, the user may describe this as a bad network, when the more exact problem is that the device never got the settings it needed in the first place. DHCP failure can also create strange results if the device keeps old information too long or receives settings that conflict with what the rest of the network expects. For beginners, the biggest lesson is that connection alone is not enough. A device can join the network at a physical level and still fail at the logical level if DHCP does not hand out the correct working information. VLAN introduces a different kind of idea because it is not mainly about naming or addressing. It is about organization. A VLAN allows a network to separate groups of devices logically, even when the hardware is physically part of the same larger switching environment. In plain terms, it helps create smaller neighborhoods inside one bigger network. That can be useful for security, performance, management, or keeping departments and device types apart from one another. For example, employee computers may belong in one group, guest systems in another, and printers or cameras in yet another. The power of a VLAN is that it gives the network designer a way to control who is grouped together without needing completely separate physical equipment for every group. For beginners, the easiest way to understand it is to think of one building with several locked office suites inside it. Everyone is under one roof, but not everyone is automatically in the same space. The purpose of a VLAN becomes much clearer when you think about why mixing everything together can be a problem. If every device shares the same open network space, traffic can become harder to manage, security becomes weaker, and mistakes spread more easily from one group to another. A guest device might sit too close to business systems. A camera network might create noise for user traffic. A printer or lab environment might need to be kept apart from finance or administration systems. By dividing devices into logical groups, a VLAN helps keep the network cleaner and more controlled. This matters in support because users often do not know they are on different logical parts of the same network. They only notice that one system can reach a printer while another cannot, or that guests have internet access but cannot see internal resources. Those are clues that point toward network grouping and access rules rather than toward a broken cable or dead device. When a VLAN problem appears, it usually shows up as missing access rather than total failure. A device may connect successfully and even reach some resources while being unable to reach others. Users in one area may work normally, while devices in another group cannot see the same printers, servers, or internal tools. A newly installed system may seem healthy, but be placed in the wrong logical group, which makes it behave as if important services do not exist. This is why VLAN issues can be confusing for beginners. The network is not fully down, and the device is not fully dead. Instead, the device is living in the wrong neighborhood or unable to cross from one neighborhood to another the way the design intended. That is a very useful picture to hold in your mind, because it turns an abstract term into a practical support clue. VPN helps solve yet another kind of network problem. Sometimes a user needs to reach a business network from far away, across the public internet, instead of from inside the building. A VPN creates a protected path that allows the user's device to communicate with the private network as though it were more safely and directly connected than it really is. The beginner-friendly idea is that the VPN acts like a secure tunnel through a public space. The user may be at home, in a hotel, or on a coffee shop network, but the VPN helps protect traffic and connect the device to resources that are meant for authorized users. That is why remote workers, traveling employees, and support staff often rely on VPN services. Without them, important internal systems might be exposed in unsafe ways or simply unavailable from outside locations. When a VPN works well, the user may only notice that they can reach company tools from somewhere else. When it fails, the symptoms can be very frustrating because they often affect access in selective ways. A user may have normal internet browsing and still be unable to reach internal files, remote systems, or private business applications. Another user may connect the VPN successfully but find that performance is slow, certain resources are missing, or the session drops unexpectedly. For beginners, the important lesson is that VPN problems do not usually feel like all network failures. They feel like a missing bridge between the outside world and the protected inside resources the user needs. If the public internet is fine, but the private work tools are not reachable, the VPN should move much closer to the front of your thinking. When you step back, these four ideas fit together better than they first appeared to. DNS helps devices find destinations by name. DHCP helps devices receive the settings they need to join the network properly. VLAN helps organize devices into logical groups so the network stays controlled and structured. VPN helps users reach private resources safely from outside the normal local environment. Each one supports communication in a different way, and each one creates a different failure pattern when it breaks. That is why this topic matters so much. It is not four random terms on a study list. It is four different support functions that shape whether devices can find, join, organize, and safely reach what they need. The main takeaway from this lesson is that confidence comes from understanding the job each service performs and noticing what kind of failure shows up when that job is no longer being done correctly. If names stop working but the connection still exists, think about DNS. If a device joins the network but never becomes truly usable, think about DHCP. If one group of systems can reach a resource and another group cannot, think about VLAN design and access. If the internet works, but remote access to private business tools does not, think about VPN behavior. That way of thinking is exactly what helps beginners grow into strong technicians. You do not need to memorize these terms as isolated facts. You need to understand how each one helps devices communicate and how the network feels when one of them stops doing its job.
Thanks for listening. For more audio courses, daily newsletters, and more, please visit baremetalcyber.com.